this is Sagarika. Welcome to SAGU'S Math. Today's topic is method of induction. It is a very important topic of mathematics. Okay. Method of induction is a process of reasoning in where some general rules are derived from specific by some specific observation. Okay. And this is a process from general to specific. Okay. So what are the procedure? Like when we add 1 plus 2 plus 3 plus up to n, then the result is n into n plus 1 by 2. Let's check by some formula. In place of putting n is equal to 5, here equal to 1 plus 2 plus 3 plus 4 plus 5. That means 5 for 9, 3 12 to 14, 1 15. Okay. According to formula, the right hand side or from right hand side n, in place of n we will put 5 into 5 plus 1 6 divided by 2, which equal to 15. Okay, like some specific formulas or derivations we got general rule. This is our general rule. Okay, there are 3 steps to solve the problem, okay, or to prove the problem. Step 1 is, listen carefully, first is step 1. We have to prove for n is equal to 1. To taking this as statement Pn, this is statement Pn. For n is equal to 1, P1 is true. P1 is true, that means the left hand side of a P1 is equal to right hand side of a P1, then we'll say P1 is true. Okay. In step 2 we have to assume that Pk is true. Okay. Pk is true. That means 1 plus 2 plus up to k is equal to k into k plus 1 by 2. Got it? In step 3, we have to prove that Pk plus 1 is true. Okay, this is the concept and overall process of this proof. Okay, first to remember, for n is equal to 1 it is true. Assume k is equal to, for n is equal to k, Pk is true, and for n is equal to k plus 1, Pk plus 1 is true. These are the procedure. Okay, now move to solve a or prove a problem. This problem first, question number 1. In this video, we'll do 5 problems and next video another 5. Okay, first question is to prove 1 plus 2 plus 3 plus up to n is equal to n into n plus 1 by 2 for all n greater than is equal to 1. Okay. Prove this by method of induction. MI means method of induction. Okay. Solution. Let Pn, taking the question as a statement, Pn is equal to 1 plus 2 plus 3 plus up to n is equal to n into n plus 1 by 2. Okay. By step 1, we have to prove P1 is true. Left hand side of P1. That means for n is equal to 1, there will 1 value which equal to 1. Right hand side is equal to 1 into 1 plus 1 by 2, which equal to 1 into 2 by 2, which also equal to 1. Okay. Step 2, assume that we have to assume that Pk is true. Okay. Pk is true. That means for n is equal to k, here to write for n is equal to 1. For n is equal to k, 1 plus 2 plus 3 plus up to k is equal to k into k plus 1 by 2. Okay. Next step. Step 3. For n is equal to k plus 1, we have to prove that pk plus 1 is true. Okay. That means in place of n. Look at it. In place of n, we will put k plus 1. In place of n, we will put k plus 1. In place of n, that means putting k plus 1 by 2. Okay. K plus 1, that means pk plus 1, that is 2. So 1 plus 2 plus 3 plus up to k plus 1 is equal to k plus 1 into k plus 2 by 2. Okay. Now taking left hand side, which equal to 1 plus 2 plus 3 plus up to k plus 1. We can write this like 1 plus 2 plus 3 plus up to k plus 1, which equal to, from this equation, the value from 1 plus 2 plus 3 plus up to k is equal to k into k plus 1 by 2. That means we can put here k into k plus 1 by 2 plus k plus 1. By taking k plus 1 as common from both sides, which equal to k by 2 plus taking k plus 1, here left only 1. Now simplifying this, we have k plus 1 into taking 2 as LCM, which equal to k plus 2. That's equal to k plus 1 into k plus 2 by 2. Okay, which equal to right hand side. So we have 1 plus 2 plus 3 plus up to n is equal to n plus 1 by 2 for all n greater than equal to 1. This will by method of induction. Okay, got it. Next to do another question number 2. 1 plus 3 plus 5 plus up to 2n minus 1 is equal to n square for all n greater than 1 by method of induction. Okay, prove this. Similarly, let Pn, taking question to us, Pn 1 plus 3 plus 5 plus up to 2n minus 1 is equal to n square. Step 1, for taking n is equal to 1, for n is equal to 1, LHS P1 is equal to first value, is equal to 1, RHS is equal to putting n equal to 1, n square, that means 1 square, which equal to 1. Now left hand side equal to right hand side, so P1 is true since left hand side is equal to right hand side. Okay. Step 2 was assume that Pn is true for n is equal to k. That means 1 plus 3 plus 5 plus up to 2n minus 1 for putting n equal to k. That means here we will put k, which equal to k square. Okay. Step 3. Move to step 3. We have to prove that pk plus 1 is true. Okay. That means in place of n, we will put k. Okay. In place of n, we will put k plus 1. Here we will put k plus 1. Okay. That means 1 plus 3 plus 5 plus of 2. 2 into, in place of n we will put k plus 1 minus 1. Okay. Is equal to k plus 1 whole square. Got it? Now from left hand side. 1 plus 3 plus 5 plus of 2. Simplifying this, it will 2k plus 2 minus 1, which equal to 1 plus 3 plus 5 plus of 2, 2k plus 1 equal to, we can write this 1 plus 3 plus 5 plus of 2. The previous term of 2k plus 1 is equal to 2k minus 1 plus 2k plus 1. Why? Because there is one difference, two difference. That means difference between 3 minus 1 is 2. 5 minus 3 is 2. Okay. So 2k minus 1 and 2k plus 1 is 2 difference. That means from this equation, the value from 1 plus 3 plus up to this 2k minus 1 is equal to what? K square plus this equal to 2k plus 1, which equal to square of k plus 1. That means k square plus 2 into k into 1 plus 1, which equal to RHS. So, hence Pn is true. Okay, that means 1 plus 3 plus 5 plus up to 2n minus 1 is equal to n square for all n greater than equal to 1. Okay. Next question, number 3 question. To prove 1 into 2 plus 2 into 3 plus 3 into 4 plus up to k into k plus n into n plus 1. N into n plus 1 is equal to n into n plus 1 into n plus 2 by 3 for all n greater than equal to 1. This is symbol of for all. Okay. Now proving this, let same procedure Pn is equal to 1 into 2 plus 2 into 3 plus 3 into 4 plus up to n into n plus 1 is equal to n into n plus 1 into n plus 2 by 3. Okay. By step 1, for n is equal to 1, left hand side of P1 is equal to 1 into 2. That means for n equal to 1. Here to put in place of n equal to 1. 1 into 1 plus 1, which equal to 1 into 2, which equal to 2. Right hand side is equal to 1 into 1 plus 1 into 1 plus 2 by 3, which equal to 1 plus 2, 3 cancel, which equal to 1 into 2. Since left hand side equal to right hand side, that means P1 is true. Okay. Next to step 2, assume that Pk is true. Okay. That means 1 into 2 plus 2 into 3 plus 3 into 4 plus of 2 k into k plus 1 is equal to k into k plus 1 into k plus 2 by 3. Okay. Taking this as our equation 1. By step 3, that means we have to prove that Pn is true for n is equal to k plus 1. That means pk plus 1 is true. Pk plus 1 is true. That means that is to show 1 into 2 plus 2 into 3 plus up to. In place of n, we'll put k plus 1. That means k plus 1. In place of n, we'll put k plus 1. Here we'll put k plus 1. Okay. This equal to k plus 1 plus 1. Which will be k plus 2 is equal to k plus 1. That means here putting n equal to k plus 1. Here also k plus 1. K plus 1. This is k plus 1. Here also k plus 1. That means k plus 1 plus 1. Which will k plus 2. K plus 1 plus 2. Which will k plus 3. Okay. Right. K plus 2 into k plus 3 divided by 3. Now solving this. From left hand side, 1 into 2 plus 2 into 3 plus up to k plus 1 into k plus 2. Okay. Which equal to, we can write 1 into 2 plus 2 into 3 plus up to its previous term is k into k plus 1 plus k plus 1 into k plus 2. We can write this, which equal to, from equation 1 we will put k into this divided by 3 plus from this up to this value. Okay, whose answer is plus k plus 1 into k plus 2. Now taking k plus 1 as common, which equal to k into k plus 2 by 3 plus k plus 2. Okay. Now simplifying this, which equal to k plus 1 into, taking 3 as LCM, k into k plus 2 which equal to k square plus 2k. Taking LCM, 3 into k plus 2, 3k plus 6. Okay. Which equal to k plus 1 into k square plus 5k plus 6 divided by 3. Now we can write k plus 1 by 3 into k square plus 3k plus 2k plus 6. Breaking 5k as 3k plus 2k. We have k plus 1 by 3 into, from these two, taking k as common, k plus 3 plus here taking 2 as common, 2 into k plus 3. Okay, which equal to k plus 1 by 3 into k plus 3, taking k plus 3 from both sides, here left k plus 2, which equal to, which is our right hand side. Yes or no? Is equal to right hand side. K plus 1, here k plus 1. K plus 2, here equal to k plus 2. K plus 3, k plus 3. Divided by 3. Okay, got it. Now left hand side is equal to right hand side. Okay. So pk plus 1 is 2. Hence 1 into 2 plus 2 into 3 plus up to k into k plus 1 is equal to k into k plus 1 into k plus 2 by 3 for all n greater than equal to 1. Okay. Next, move to question number 4. To prove 1 square plus 3 square plus 5 square plus up to 2n minus 1 square is equal to n into 4n square minus 1 by 3 for all n greater than is equal to 1. Okay, let Pn is equal to this. Step 1. For n is equal to 1. That means in left hand side putting n is equal to 1. That means 2 into 1 minus 1 square, which is equal to 1. Okay, or you can take from first. Right hand side 1 into 4 into 1 square minus 1 divided by 3. 4 into 1 square 4 minus 1 3 by 3 which equal to 1. Okay. Since left hand side is equal to right hand side, that means P1 is true. Okay. Next move to step 2. Assume that Pn is true for n is equal to k. That means we will put in place of n is equal to k. 3 square plus 5 square plus up to 2k minus 1 square is equal to k into 4k square minus 1 divided by 3. Okay. Step 3. Step 3, we have to prove that pk plus 1 is true. We have to prove that pk plus 1 is true. That means that is to show 1 square plus 3 square plus 5 square plus up to 2 into k plus 1 minus 1 its whole square is equal to n into 4 into k plus 1 whole square minus 1 divided by 3. Okay. Which equal to 2 into k plus 1 minus 1, 2 into k plus 1, 2k plus 2 minus 1, which equal to 2k plus 2 minus 1. 2 into k, 2k, 2 into 1, 2 minus 1. 2k plus 2 minus 1, which equal to 2k plus 1, its whole square. Okay. Now, 1 square plus 3 square plus 5 square, we can write it to up to 2k minus 1 square plus 2k plus 1 whole square, because its previous term is 2k minus 1. That implies putting its value k into 4k square minus 1 by 3 plus 2k plus 1 whole square. Okay. Which equal to k into, we can write 4k square as 2k square, 1 as 1 square divided by 3 plus 2k plus 1 whole square, which equal to k into, by the formula a square minus b square equal to a plus b into a minus b. Here 2k equal to a and 1 equal to b. Here we can put 2k plus 1 into 2k minus 1 divided by 3. Plus 2k plus 1 whole square. कपड़ बंद कर दो. which equal to taking 2k plus 1 common. 2k plus 1 which equal to k into 2k minus 1 by 3 plus 2k plus 1. Okay, that's equal to 2k plus 1 into taking 3 as LCM, 2k square minus k plus 3 into 2k plus 1 which equal to 6k. 3 into 2k 6k plus 3 into 1 3 which equal to 2k plus 1 into 2k square plus 5k plus 3 divided by 3. Our right hand side was k plus 1 into 4 into k plus 1 square minus 1 divided by 3. Okay. But this was our right hand side. Which equal to k plus 1 into, we can write 4 is equal to 2 square k plus 1. That means we can write 2 into k plus 1 its whole square. We can write or not? Yes, we can write. Divided by 3. That means k plus 1 into 2 into k plus 1 which equal to 2k plus 2 into 1 2 its whole square minus 1 square. We can write like this divided by 3 which equal to of the form of a square minus b square, whose formula is a plus b into a minus b. In place of a, this is 2k plus 2. In case of b equal to b, which equal to a square minus b square. That means k plus 1 by 3 into 2k plus 3 into 2k plus 1. 2 minus 1 equal to 1. Here 2 plus 1, 3, 2 minus 1. Now to check left hand side, k plus 1 into 2k plus 2 into 2k plus 3. Now left hand side is equal to right hand side. Okay. Therefore, Pn is true for all n greater than is equal to 1. Okay. Now question number 5. 1 square plus 2 square plus 3 square plus up to n, sorry, those are cube. 1 cube plus 2 cube plus 3 cube plus n cube is equal to n into n plus 1 by 2 square for all n greater than equal to this. Proved by method of induction. Let Pn is equal to 1 cube plus 2 cube plus up to n cube is equal to n into n plus 1 by 2 its whole square. Okay. Step 1. For n is equal to 1. P1 is equal to 1 cube which equal to 1. Okay. This equal to our left hand side. From right hand side, 1 into 1 plus 1 by 2 whole square which equal to 1. 1 plus 1 by 2, 2 by 2 cancel, 1 square is equal to 1. So, left hand side is equal to right hand side. That implies P1 is true. Okay. Step 2. Assume that Pn is true for n is equal to k. That means 1 cube plus 2 cube plus up to k cube is equal to k into k plus 1 by 2 its whole square. Okay. Step 3. In step 3, we have to prove that pk plus 1 is true. That is to show 1 cube plus 2 cube plus up to k plus 1 cube is equal to, we'll put k plus 1 into here in place of n we'll put k plus 1 plus 1 by 2 its whole square. That means k plus 1 into k plus 2 divided by 2 its whole square. Okay. One cube plus 2 cube plus up to k plus 1 its whole cube, which equal to 1 cube plus 2 cube plus up to its previous term is k cube plus k plus 1 cube. From this, from equation 1, we have k into k plus 1 by 2 its whole square plus k plus 1 its whole cube. Okay. Now we can write k square into k plus 1 square divided by 4 plus k plus 1 cube. Here taking k plus 1 square as common. Okay, that's equal to k square by 4 plus k plus 1. Okay, which equal to k plus 1 square. That means k plus 1 square goes outside and only left k plus 1. 4 as LCM, which equal to k square plus 4 into k plus 1. That means 4k plus 4. Okay. Which equal to k plus 1 by 2. K plus 1 by 2 square into left k square plus 4k plus 4. We can write k square plus 2 into 2k plus 2 square. Okay. Which equal to k plus 1 by 2 its whole square into which equal to k plus 2 whole square. A plus b whole square form. That's equal to k plus 1 into k plus 2 by 2 its whole square. Okay. Which was our right hand side. Yes or no? K plus 1 into k plus 2 by 2 whole square. Okay. Thank you so much for watching this. It will very needful for all your semester exam or your plus 2 first year exam. Okay. Thank you so much.